Okay. All right, regular expressions. So regular expressions they're actually fairly difficult to use in, they're difficult to get correct. So it's easy to write a regular expression that seems to work, but it's hard to find a regular expression that always works, which is part of the problem. So regular expressions are sometimes used to validate input. And if you have a regular expression that accepts, that seems to work, right? So in other words, it seems to correctly validate input, but in fact is incorrect, then what you end up with is is the danger that you'll end up accepting input that's not valid, which is dangerous in many cases. So for example, how can you validate an email if you search the internet, you'll often find a question similar to how can I validate an email address with a regular expression. So an email address is something, and then @ and then something, right? And people often come up with simple regular expressions that seem to work, right? So for example, that. But it turns out the simple the simple regular expressions for something like an email address doesn't work. And whoever wrote this page, or whoever maintains this website, regularexpressions.info, went through a lot of trouble about how to talking about how you validate email addresses with a regular expression. And it turns out, if you go down to the bottom of the page, that's the regular expression that you would need to write that checks for the quote unquote preferred syntax of an email address, right? So good luck coming up with that on your own. I can't even read this, like I don't even know what it means. So I mean, in short, you're never going to be asked to reproduce a regular expression like this. Any regular expression used in this course will be relatively straightforward. Right? You'll have to write some. Don't worry about trying to conjure up something like this in this course. Right? I actually don't know if you'll see regular expressions later on in any other follow-up course to this. I can't think of one where I can't think of a course where it would be a requirement, but you never know. They are useful. All right, so let's pick up with this is lecture 10 if you're following along on the lecture slides. So it's shell scripting part 4. Okay, so grep is one of the more commonly used programs in Unix that will accept a regular expression as input. So it is an enormously useful program. What it lets you do is it lets you search a file for one or more occurrences of a regular expression. And that turns out to be incredibly useful because a lot of software will write information out to a text file of some kind. And you'll often want to search that text file for information. An example, so in most programming languages use plain text to represent a program, right? So you might have a Java program and you might need to search your Java program for a particular method call, for example, right? Grep is one way to do that. The other thing grep lets you do is it lets you search multiple files at the same time. So for example, if I have all of your assignments downloaded into separate directories somewhere, right, and I find someone's assignment where they're doing something weird, I can quickly find out if someone else is doing the same weird thing by using grep, right, which lets you pretty easily find people who are not doing their own work, right? So that's one easy way that I can use to track down people who are, well, we'll just say not doing their own work. it's very easy to do if you're doing something unusual, right? And grep makes it trivial to search for all the files that contain the same unusual construct. So grep searches a file or files or standard input for lines that match a regular expression. Now, Bash uses the extended regular expressions. So if you're going to use grep with the regular expressions that I've been talking about, you should probably use the -big E option just to be safe, because otherwise grep uses something called the POSIX basic regexes, which are a little different. Most of the time things will work, but then there's a few differences. Right, so the way you use grep, it's just grep. You should, for our purposes, you should use -E. There are a bunch of other options you can use. Then comes your regular expression, right? So this is your string describing the pattern that you want to find. And then this is the file or list of files that you want to search. Right? And you can invoke grep recursively. So you can search for all the files in a folder and in any subfolder of the folder. So it's got lots and lots of options that you can use. Here's an example of using grep in a pipeline in this case. So I can run the ls command in my root user bin directory. Right? So list all the files in user bin. I can take that result, right? That gets printed to standard out, right? So I can take standard out. I can pipe it to the input of grep. Okay? So I can look at the output of ls. For any regular expression, for any file name that contains the word zip in the file name, right? Not in the file name. So let's take a look at that. So let's try that ls. So if I do ls root user bin, right? On my computer, it spits out a bunch of stuff, right? You can see there's a bunch of files that start with zip. If I want to find all the files that start with zip, then I can do it using grep if I wanted to. So for example, pipe to grep and zip. Okay. Now, remember that's our regular expression, right? I don't have any of the anchors on the regular expression. So this will look for all file names that contain zip. Right, and there you go. Right, you can see there's a bunch of them. Right, if you're on a Mac, you won't have this many. But if you're on the Windows subsystem for Linux, you've probably got most, if not all, of these. Right. So we can do that. If I want to find all the files that start with zip, right, I can use the anchor, right, and so that will list. That should list all of these ones here, and it does. If I want to find all the files that end with zip, I can use the anchor at the end, right? And that should list, does that list anything? Yeah, it lists a few of these up here. Should list those 5, I guess. Oh, and zip itself, so it should match 6, and it does. Right. So there's an example. That's one simple example of using grep in a pipeline. Here's an example of searching a Java source code file to find all the lines that start a for loop. Right. So grep -E, n turns on numbering, line numbering. That's useful if you're looking at a source code file, right? You want to know what line number the file's on, the line is on. Right. I'm going to search for. I'm going to search for the keyword for. Right, and I'm going to, I guess, look in this file here. That's probably Java, allwords.lookup.java. So that's a typo, right? I don't actually have this file in my directory on this computer, so this isn't going to work. I can't demo it for you. But what this will do is it'll look through this file here, right, and print out the line number and the line containing the word for. Right now, if you're searching a source code file, you probably, and you're looking for a for loop, then you probably don't want to look just for the string for, right? Because if you've got a variable that contains the word for, or if you have a comment that contains the word for, or if you have, what else? Anything, well, basically any piece of text that contains 4, then grep will find that line. So if you want to be a little more specific, right, then you can actually try to look for the for construct in Java. Right? Now remember, what does a for loop look like in Java? Well, it starts with the keyword for, right? Then there might be 0 or more blank spaces, right? So you can use a space or a tab in Java as white space. So the character class blank is any white space. So that's a space, a tab, a new line character. And there might be other ones in there as well. Right, so I'm going to look for 4, then some white space, followed by a round bracket, right? Because a for loop always, the condition for the for loop always has the round bracket, always starts with the round bracket in Java. I have to escape the round bracket because the round bracket has a special meaning in a regular expression, right? So I need to escape the round bracket. So that'll match anything, anything that's for, space, and then a round bracket, right? Again, that should be Java, not zip. So that's a little bit better. It still doesn't completely solve the problem of returning false positives. Right? So for example, if you have a line of code that's commented out, but you've commented out a for loop, then this expression will also find it. There's no good way to search to exclude lines of code that are commented out. The reason being is because in Java you can have a multi-line comment, right? So you can use /* to start a comment, and then */ to close the comment. That can be arbitrarily long, and so there's no good way to write a regular expression that will ignore commented out statements. Okay, if you know anything about HTML, you know that an HTML document, so that's just a web page, or it's one way to describe a web page. An HTML document basically contains these things called tags, right? So an anchor tag, so that's something you can click on, always starts with a less than and then an A, right? And then there might be a space. Well, there's, the spaces. You can technically have just an A tag, but that doesn't do anything. So normally there's a space after it, right? So I can look for all of the anchors in an HTML document using this regular expression here, right? So this time it's quoted because I want the space to be part of the regular expression. That's the name of the file you want to search. Again, the N will print out the line number as well. If you have the spell program installed on your computer, so in Linux. I don't know if Mac keeps it in the same space or not, in the same location or not. But you can certainly install spell on Mac if you wanted to. But on my computer, I think I have spell installed. We'll find out in a second. Spell is basically it's a simple dictionary program that you can run from the command line, and it stores the list of words here. So let's see if this works. So I'm going to do grep -ei. Right. So remember that's the start anchor. Right. .ak. I'll explain that regular expression in just a second. Is this here? Oh, this may not be here. Dict. Oh, what did I do wrong? Oh, sorry, forgot the closing double quote. Okay, so it is here. All right, so what are we doing here? So we're looking for words, right, that start with any character, followed by an A, a K, any character, followed by an S. Right. So if you're like playing crossword puzzles or any other word puzzle, then you can use grep to help you solve the word puzzle. Right. So this will look for any five letter word that has an A in the second place, a K in the third place, and an S in the end. Right. And so these are the words that are in my dictionary file on this computer. If you play Wordle, this is an easy way to solve Wordle. Compound, oh, this is completely unrelated to regular expressions. All right, so that's the grep program. That's a very quick introduction to the grep program. Grep is actually very powerful. You can do lots and lots and lots of things with grep. In fact, there are entire books written about grep. So it's not something that you can completely describe in a single lecture or even in several lectures, right? But the upshot is it will search a file for a regular expression for you. A compound logical expression. So I think this slide is here because I forgot to include it where it should have been last term. So when you're writing an if statement, often you want to check for more than one condition. So you want to use some sort of logical operator, right? I want to use and or. You can use and or in the bash if statements, right? No, sorry, in the condition for a bash if statement. So if you're using the single brackets for your test expression, then you can write your expression. If you want and, then you write minus a, and then you write your second expression. Right? If you want or, you write minus o, and then your second expression, right? With a space around the before the hyphen and after the a, right? Which looks really weird. Which is another reason why you should probably not use the single square brackets when writing your expressions. If you use the double square bracket or the double round, the double parentheses construct, then you can use a double ampersand or double vertical bar. Right. You should probably, if you're strictly doing bash programming, you should probably prefer the double square brackets. If you're ever in the situation where you are working in Unix and you are concerned that your shell scripts have to be portable, so there's lots of people who might be using your scripts, then you should probably use the single square brackets, because these are the only ones. The single square brackets are part of the POSIX standard. Double square brackets are more common in Linux and in certain other shells. Right? But because bash has the ability to use the double square brackets, it tends to be more common in Linux. Okay. Occasionally, you will want to read keyboard input. Now, I say occasionally because most programs that you write for a shell as a shell script, normally they take input from the command line as command line arguments, right? So you type in your command and then you feed it all the information you want on the command line directly, right? It's a little bit unusual to write a program that prompts you for input. At least it's unusual outside of an academic setting, right? So outside of a first or second year programming course, it's somewhat unusual, although there are some programs that do it. If you're in the situation where you want to read input from the user, so you want to ask the user to type something in and then accept input from the standard input, the command read will do that for you. So read is a bash built-in command. So help reads, right? So there's no man page for it. You either use help or you use man built-ins. Okay, so what does read do? Read reads a single line from standard input or from a file if the -u option is supplied. The line is split into fields as with word splitting. So in other words, wherever it sees a space, it will do word splitting. And then it can assign the individual strings from the input to variables if you want, if you ask it to. All right, so I'll show you an example of that in a second. Is there anything interesting here? -p is interesting. So -p lets you print a prompt and then read the input. So that's if you want to prompt the user, then it's common to use -p. And there's a few other things you can look at here. Okay. So here's an example of asking the user. Oh, this is even again. Right, so this time so this version of is even will accept command line arguments, right? So I can write is even 5, in this case, is even 5 and then some number, right? If I don't write a number though, right? So if the number of command line arguments is 0, right? Then instead of exiting with an error, I'm going to prompt the user to enter in an integer. Right? So the way you use read is as follows, right? You use read minus p for the prompt. Then you give the prompt, right? So that'll get printed out. And then a list of variables where you want to store the input that the user has typed in. Here I'm expecting a single value, right? So I'm going to read whatever the user types in into one variable called val. Now, if the user has entered something, right? So if there's one or more command line arguments, then I'm going to take the first command line argument as the value. Right? Everything else is the same, right? There's our regular expression for checking for integers, right? And then there's our remainder operation to check if the number is even or odd. Not that one, this one. So is even 5. So there it is there. Comment is wrong. So when we run this, so if I run it the normal way, right? So I give it some command line input, it runs, right? Remember, it exits with a sorry. Exit if it's even, it exits with 0. Right? If it's odd, it exits with 1. Right? Now, if I don't type in anything, press enter. Now I get the prompt. Right? So now it asks for an integer value. So if I type in some integer value like 99, it does its thing. Right? That should be odd, and it is. Right? So you get a 1. If I type in an even number, sorry, nope, I had it. There we go. Right? That should be even, so I get a 0. If you type in, there's a bunch of spaces here. It ignores those, right? So the bash is smart enough to know that there are no command line arguments in this case, right? And if I type in something illegal, you get the error message here. So there's an example of using the read command. There's another example of using the read command. Read will read into multiple variables if you ask it to, right? Anywhere there's a space in the user's input, that's where the word splitting happens. Right? So word splitting happens as usual wherever there's spaces. So this is read 3. So this is going to ask for 3 or more values on the command line. There one or more. This act 1 or more. What did I write? Sorry. What did my oh, enter 1 or more values. Okay, so let's try 1. A, B, C. It tells you that var1 got assigned the value A, B, C. var2 and var3, they got no value assigned to them. Type in 2 arguments, so A, B, C, E, F, G. Right. var1 gets assigned A, B, C. var2 gets assigned E, F, G. var3 is not assigned. You do 3, right? Then obviously that happens. Now the question is, what happens if you type in more than 3? Right? So A, B, C, D, E, F, G. So E, F, G like that. Okay, so what happens here is that gets assigned to var1. That gets assigned to var2. Everything else gets assigned to var3. Oh, sorry. A, B, C, C, D, E, F, G. There we go. So the A, right? So everything happens as usual until you get to the last variable, and then everything else gets put into the last variable. Right. So that's sometimes useful as well. And then finally, read can read into an array. So Bash has arrays. They're really clunky to use in Bash, I think. So we're going to talk more about arrays, I think, in the next lecture. But for here, or for now, I'm just going to use read to read into an array. Now, the way you read into an array, if you want to do so, is you use the -a option. Right? So minus A, and then that's the name of the array where all the values will go into. Now in Bash, the arrays are dynamically sized. So they sort of act like lists in Bash, right? You can add as many things as you want to an array. They don't have a fixed size or anything like that. This funny syntax here, right? That's how you get the number of elements in an array, right? So $, array name, square bracket, at, right? Closing square bracket. That's the syntax that you have to use, right? So that's the number of elements. Actually, you have to do all of this. So $, brace, hashtag or number sign or pound, variable name, and then all of this, right? So it's really awkward to get the size of an array in Bash. And then here's a for loop, which we'll see, I think, in the next lecture, right? So that's a counting style for loop in Bash. Looks almost exactly like a Java loop, right? And then that's how you get an element out of an array, right? Or how you access an element in an array. So this one will read however many values you enter into an array. Oops, nope, not that one. Is it here? Read n. Enter one or more values. So A, B, C, D, E, F, G, 1, 2, and 3, like that. Okay. When you do that, you can see that the array elements, each string here gets assigned to its own array element. Right? And of course, the strings don't have to be a single character long. You can make them as long as you like. Right? So, and each continuous string gets assigned to its own element. Okay, so how does Bash know, or what does Bash split on when it does word splitting? So word splitting is performed wherever there's white space. Now, Bash defines the characters that are used for word splitting in this variable called IFS. So it's the short for internal field separator characters. Right? So this thing IFS, it's just a string. Right? So it's a string containing all of the characters that are used for word splitting. You have access to this variable, which means you can change it. So you can split on different characters if you want to. And this is occasionally useful. By default, IFS includes the space, the tab, and the new line. Right. So it doesn't include things that look like spaces but are not the official space character or the new line character. So you can change IFS if you change it, especially if you're doing it from the command line instead of a script. So if you change it on the command line, you really should set it back after you're done, because otherwise, if you don't change it, every program that uses IFS to do word splitting will now split using the new version of IFS, right? The modified version, which could break a lot of scripts. Okay, so here's an example of using IFS. I want to print the contents of path, 1 per line. Now, I should remind you what path is. Or path is the list of directories that the shell will search for an executable program or script. It splits on the colon, right? So every time there's a colon, that's the separator between directories. Did this come up in 220? No, this didn't come up in 220. One thing you should not do is you should avoid creating directories with colons in their name. It's legal, so you can do it, right? You can do it in Linux, you can do it in Mac, you can do it in Windows. So you can, I think you can do it in Windows. I'm not 100% sure if you can do it in Windows, but you can certainly do it on a Mac. The problem is if you put a colon in the directory name, then programs that try to interpret the path or assume or internally use the colon to split up directories like the path variable, right? Those programs can fail if they don't account for colons in directory names. Eclipse is one of those programs that will barf if you have a colon in your workspace directory name. And this happened to a student this term in CMPE 212. That's the engineering version of 124. So they created an Eclipse workspace. They didn't even make a workspace directory. Their home they created a directory in their documents folder called 2021:22, and then put their workspace directory in that directory. And Eclipse barfs when you do that. So don't put colons in your directory names. Okay, so what's this doing? This is going to, I want to split that path variable on the colons, right? So I can do that by changing IFS, right? So I'm going to store the old old value of IFS, right? The current value, I'm going to change it to the colon, right? I'm going to use read to read into an array, and I'm going to feed it the path. So this is kind of cool. That thing there, that's called a here string, and I'm going to explain what that does in a minute. Right now, read normally takes in a variable, right? So it normally takes in it normally takes in standard input, right? Normally it reads from standard input, but you can use a variable in place of standard input by using this triple less than construct here. That's kind of cool. So I can feed a variable to read, and I can let read split the path and store the individual elements in the array. Right. After read is done splitting, I set back I reset IFS back to the original value. Then I can print out the directory contents. The array contents in the same way as the previous example. Let's see if this works. So that's kind of neat, right? So if you want to, if you need to do token splitting somehow, right, using where you're splitting a string at some kind of delimiter character, then read is one way to do it. Right? Okay, so what is that funny triple less than sign? So that syntax there uses what's called a here string. So that, right, all of this is called a here string to slide input to read. So what happens here is whatever the value of path is, right? So path is a variable, right? So whatever value path has gets expanded into a string, and then that string is fed to the standard input of this command here, right? So that's what that thing there does. Right? So that feeds whatever this is into the standard input of read. Right? And that works here because read reads standard input. Right? It's one of these. It's one of the programs that wants to read standard input. Right? And what I really want to do is I want to feed it the contents of a variable. Right? And so read can't do that natively. So you need the here string construct in order to convert the variable into standard input. Convert the variable and feed it to standard input for the command read. Here's another example of the here string. So grep wants to either read the contents of a file or it wants to read standard input. Right now, if you want to search if you happen to have something stored in a variable, right, and you want to search that variable for all occurrences of a regular expression, right, then you can use grep, but you need to use the here string construct to feed the variable contents to grep, right? Because again, you can't grep a variable, right? But you can grep standard input. So I can take the variable and send it to the standard input of grep. -q means quiet, so it won't generate any output in this case. Right? Grep normally prints all the grep normally prints all the occurrences of a string of a regular expression. If you use -q, grep outputs nothing, even if there is an error. Right. So here I'm just searching this variable to see if this variable contains the sequence txt. A little program. I think I put this into a program. So here it is. So I've got a little script. Right? It takes its command line argument and stores that in var. Right? It feeds var using a here string to the standard input of grep. It uses grep to look for the substring txt. The other way to do this is to use equals tilde inside of square brackets. Right. So you can use the double square brackets and the regular expression matching operator for the double square brackets. So we can try that one out. So I'm looking for the string txt. Okay, so A, B, C, D, E, F. Right, so it does nothing. Right, .txt. Now it says it contains the substring. It contains the sequence txt. Right, and that txt can appear anywhere inside the string. So it doesn't have to appear at the end. Right, it could just be at the front. After it, there can be a bunch of stuff before it. So that's an example of using a here string to pass the contents of a variable to the grep program. Here's another example of using a here string. So if you, instead of asking the user to type in some input, right? If you've got the input that you want to parse already stored in a variable, right? You can use read to break that string into the individual substrings by passing the string into read using a here string. This uses read to split that string into its individual substrings, and it stores the individual substrings in the array, right? So -a in the array words. And we'll be looking at arrays in the next lecture. So this is here too, right? So you run that, and it does exactly what we want it to, right? It splits individual substrings of string and stores the individual substrings into the array words. Okay, now you might wonder why you don't pipe the output of echo string into read instead, right? So you can echo the string, right? And that will send the output to standard output, right? And then you want, and then you know that you can pipe the output of a command into the input of another command, right? And so you might wonder why we just don't use a pipe to pipe the string to the standard input of read, right? And the reason we don't do that here, and the reason you can't do that here and have it work, is because of the way pipelines work in Bash. Oops, sorry. Here we go. Okay, so when you create use a pipeline, that command there, that command runs in what's called a subshell of the current shell, right? So in other words, what happens is this: when Bash sees a pipe, when Bash runs a pipeline, that command Bash creates another shell, right? So the Bash shell creates a second shell to run that command, right? So that second shell is independent of the first shell, right? So this command, so read, actually reads the contents of that string into the variables var1, var2, and var3, right? So it does work. Problem is var1, var2, and var3, they exist in the second shell. They don't exist in this shell, the shell that echoed the string, right? So it works. var1, var2, var3 get set, but then this command returns. The subshell goes away, and that means var1, var2, and var3 also go away, right? So the subshell gets destroyed, and that means var1, var2, and var3 don't get set in your shell, right? They were set in the subshell, but then the subshell disappears. So that's why you can't use this construct with read. And then finally, every once in a while, you do want to write a program that's driven by user input. Right? So occasionally you do want to write a script where you want to ask the user to type in something, right? Maybe to pick between options, maybe to give input, something like that. So here is an example of using read and user argument validation to write a menu-driven script. Too long to fit on the slide, so it's separate here. This one's interesting because it also uses, well, I'll explain that in a second. So the script here, does this work? How do I, no, I can't change it. Is there any way? No, there's no good way for it. Well, I guess we'll live with this. All right, so hopefully you can read this. So the first thing we're going to do is we're going to clear the screen because this is a menu-driven program, right? So if you want to clear your bash terminal, there is a command called clear that will do so. Now, we haven't done this yet, but echo will echo, it'll print the string, its string argument, the standard output. Now that string argument, you can split that over multiple lines. So you can write echo opening double quote or single quote, right? And then you can have a multi-line string. And so echo will actually print all of this stuff out like that. So this little program is just gives you a small menu that lets the user choose between 4 options. We use the read command to read the user's choice. Right now, notice there's no variable here, right? So if there's no variable, then how do you get to the value that was typed in by the user? If you go to the help for read, where'd it go? Somewhere there. Okay, so read has some options, has some options, has some options, has some options, right? Blah, 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 blah. And these are the names of the variables that you'll store the input in. So if no names are supplied, then the line read is stored in the variable called reply in all caps. So I'm going to use, we'll use the variable name reply to represent where read stores the user input. All right, our first if statement uses equals tilde, right? So it's going to compare reply to the following regular expression. Okay. So what's that regular expression? Well, starts with, right, a 0, 1, 2, or 3, right, and then ends. Right? So that regular expression matches 0, 1, 2, or 3. You need the anchors, otherwise it will match any string that contains a 0, 1, 2, or 3. Okay. So if the reply is a 0, 1, 2, or 3, we'll do something, otherwise it prints invalid entry. So let's try that. Read menu. Okay, so there you go. Right. So I'm going to enter 9, and it says invalid entry. If I type in a value between 0 and 3, right, I can write a sequence of if statements to deal with each case. Right. So if the reply is 0, we exit the program, right, because that's quit. If the reply is 1, then this apparently is supposed to display the system information. Right. So in this case, system information is the name of my computer. Right. So that's what host name is. Right. $ all caps host name. That's the name of my computer, whatever it happens to be set to. Uptime is the command that tells you how long the current shell has been running for. So let's try that. So if I type in 1, it spits back the host name is desktop, whatever that is. That's just the name of, well, you can see it up here. So that's just the name that was given to my to this Ubuntu installation when I installed it. I didn't change it, so it's whatever the default is. Uptime, you can see it tells you how long this shell has been running for. So apparently I've been running for 1 hour and 27 minutes. It tells you some other information as well. You can just type in man uptime if you want to know about it. 2 displays disk space. Right? So this tells you how much, this is going to display how much space is available on all of the storage devices on this computer. Okay. So if the reply is equal to 2, right, the command here is df and df. So df is report file system disk space usage. -h is human readable. So let's try that. And it tells you, apparently I have a lot of hard drives or a lot of storage drives on this computer. Right? Most of these aren't actual, don't correspond to actual physical devices. Right? TempFS, that's where Windows sticks the Linux subsystem. Right? The actual drives are here. Right? And over here it tells you stuff like what's the capacity of the drive, how much is used, how much is available, et cetera, et cetera, et cetera. Right? And then finally, 3, display home space utilization. So this tells you, this is going to print out how much disk space my home directory is using. Right? So if reply equals 3, so that's the du command, right? So let's look at du. Estimate file space usage. So we're going to use du minus sh. Okay, so minus h is human readable, and s is, where's s? Summarize. Right? So it's only going to display the total. And the input is $home. All right, so what's $home? So $home is the name. So it's the environment variable that stores the location of your home directory. So essentially this runs du like this. Like that. Right, so it says that my home directory, which is where all my files are kept, right? Apparently I have 231 megabytes of files in that home directory and all of its subdirectories. And so if you run that program and type in the 3, that's what you get. So if you're ever in the situation where you want to write a program like this, read is handy, right? The regular expression is useful for validating whether or not the user typed in a correct option, right? And otherwise, this is just a bunch of if statements. You can rewrite this using a case statement if you know what one is, right? If you want to do it that way, just look up how you write a case statement in Bash. It's a little bit weird in Bash, like everything else, but there is a case statement as well. All right, time 2:20, perfect. So that's the end of this lecture. Anybody have any questions about the lecture material or the assignment that's due in a couple of days? Anybody? When's assignment 1 going to be due? I mean, you just, it's on OnQ, right? OnQ tells you when it's due. There we got your final mark back on, those were on OnQ. No, OnQ won't give you back your final mark for 124. I don't know if it's been, if your marks have been updated yet on Solus, but they were given to the undergraduate assistant. The problem is because of its deferred, yeah, so because it was deferred, the undergraduate assistant has to manually enter in all the marks. So, yeah, that's kind of gonna suck. Dallas, what's your question?
Hi, I just had a question because for some reason, when I got to question 15, when I was trying to unzip it, my computer was being like really weird and saying that I couldn't find it.
Did you run the unzip command in the same directory?
Yes.
Where the zip file is located?
Yes. Yes, I made sure that it was in there.
Yeah. Can you share your screen?
I don't have it. I sent a picture to your email for.
Okay.
Yeah.
Let me take a look.
Okay.
Oh, are you on a Mac?
No, window.
That's harder to solve. Okay. So there is a workaround if so I'll describe you the workaround and then I'll take a look at the picture.
Okay.
So the workaround is to unzip the folder in Windows. Right?
Okay.
So you downloaded the zip file in Windows, just unzip the zip file in Windows.
Okay.
And then in Linux, right? So I assume you're using the Windows subsystem for Linux.
Yes.
So you've got like Ubuntu or something installed.
Yeah. Yes.
Okay. So in your Linux command prompt, go to the directory where you want to do your assignment.
Yeah.
Right. So CD CISC 220 whatever assignment 1 or whatever.
Yeah.
And then type explorer.exe space period. Right?
Oh, okay.
An Explorer window, and then just drag and drop the files over.
Okay, perfect. And then I don't have to do the unzip.
Yeah, you don't have to, but I mean, there's no reason why it shouldn't work.
So for that question, would I just explain how I got there from using the Windows?
Oh yeah, right. What does that question say exactly? Hang on.
Yeah.
I forgot. Let me see.
Pull it back up. It said it was what's the sequence of commands that you would use?
Oh. Okay. Okay. Huh, it doesn't work, eh?
Yeah. So would I just put like how it should work as my answer?
Sure.
Like unzip?
I would,
okay.
yeah. I would just say unzip. Yeah, so what sequence of commands? Okay, so 1 is going to be your curl command. 2 will be unzip.
Yes.
So you just write unzip unzip space the file name.
Perfect. And then for question 10, so that one, I did get it to like show everything, but then it was also showing the files that weren't hidden. So while I was like listening to your lecture today, I was wondering if should I echo it and then look into it? Or
no.
Okay.
Here you want to use here you just want to use ls. So you want to use ls to list all of the hidden regular files, right? So you want to write something, ls something that will only list files that start with a dot.
Mm-hmm.
So that's the trick. Now the problem is, the problem is, so it's going to have a dot and then something else, right?
Yeah.
So if you wrote that, why don't I just show you?
Yeah. Is there a way to like exclude the?
Yes, there is. That's actually the point of the question. It's trying to get you to exclude it.
Yeah.
So let me.
Yeah, I excluded it when I did the find command, and then it worked perfectly. But it.
Yep. Yeah, using find you can exclude it. So the problem is when you're using ls, you have to be, you have to know how to, you have to figure out what exactly it is you want to exclude.
Yeah.
So that's the problem. A1. This is supposed to be working, right? Working.
Yes.
Right. Okay. So if I do ls, so I assume you did something like ls star, right?
I did. I took ls minus capital A minus R, so I recursively looked through it.
Like that.
A capital R.
Okay.
Yeah. And then it will show. It shows like the late, and then, but it also shows the ones that aren't hidden.
I'm sharing my desktop, right? Yeah.
Yeah. Yeah.
You can see it, right? So
Yes.
did you get something like that?
Yeah.
Okay, so that's not quite what you want to do,
Yeah.
right? Because what you really want is you want to see the directory name slash something,
Yes.
right? So I can do star slash, right?
Yeah.
So star slash means match any directory name and then list whatever's in that directory, right?
Yeah.
Now, if you do slash star slash star slash star, right?
Yeah.
You're gonna get something like that,
Yes.
which is close. Let me put in a 1 so that we can list everything separately. Okay, there we go. So that's close, except now it's not giving me the hidden files.
Yeah.
Okay, so now you might try dot star, right? Because
Yeah.
dot will match anything. And now I get this, which again is not quite what I want, right?
Yes.
Okay. So now you keep on monkeying around with it, right?
Yeah.
Oh, it's funny, right? So you can actually see it actually goes up. It uses, it actually matches star star and then goes back up.
Yeah.
Right? Which is kind of funny. All right, so what does it, how specific do I say? Ah, yes, so your command should not try to explicitly exclude listing. Okay, so
Yeah.
what you really want to do here is you want to match all files that start with the period, right?
Okay.
And only the period. So you can create a character class. Right? So I can do that.
Oh, okay.
Now, let's see what happens. Oh, wait, no such file or directory. So that doesn't quite work, right? Not access, blah, 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 blah.
Mm-hmm.
Right? That doesn't quite work. But I really want it to start with a period here, right?
Yes.
And the key is to, it should start with a period and then there should be something that's not a
A
period.
period. So would you
Right?
use like the caret or the? Okay, yeah.
So you have to create a character class. You have to exclude the period. And there you go.
Perfect. Thank you so much. That
That's how
makes
it
a
works.
lot more
So you have
sense.
to work through that sequence of logic.
Yes.
And it's easy to not realize that's what you need to do.
Yes.
Yeah.
Yes, because I was confused because when I was like going through it recursively, it was just giving me
Yeah, it
everything.
doesn't do what you want, right? It's like,
Yeah.
yeah. No, but there is a way to do it. It's just you have to realize that you want to exclude the period from the second location.
Yes. Yes.
Okay.
Okay, that makes a lot more sense. Thank you so much.
You're welcome.
Perfect.
Anybody else here? Any other questions before I take off? All right. Oops.